Okay. Today we are going to learn some properties that used to write the two-column proof. Addition property of equality. If two terms are equals, then if you add the same value to both of these two terms, equivalent kept. For example, if 2 equals 2, so 2 plus 3 is the same as 2 plus 3. So this is the addition property of equality. Subtraction property of equality is the same but with subtraction. So if I subtracted the same amount from two equivalent values, the equal sign kept. And I've been introduced this before. If you went to the kitchen and you found the scale and balance has 1 kilo of apple here and another kilo of apple here. You went hungry and you wanted to eat 2 apples. You took it from here, so the balance changed, isn't it? No, it will be like this if you took from here. To keep it equal again, you should take 2 apples from the other side just to keep the equivalent. So this process is called subtraction property of equality. If you are adding here and there the same amount of apple or the same number of apples, then it's addition property of equality. It works also for multiplication and for division, but we don't divide by 0, by the way. So multiplication property of equality, when I multiply the same value to 2 equal parts. So if A equals B, then AC equals BC. Easy?
Easy so far.
The same with division. If A equals B, then A divided by C equals B divided by C. Just make sure that the denominator is not 0, because if you are dividing by 0, you are getting an error. It's an undefined value. Reflexive property of equality. What does reflection mean to you? Like if you have a mirror like this, so I am equals myself. So A equals itself. This marker equals itself by reflexive property. So we have reflexive property of equality when something equals itself. Associative property of equality. If A equals B, then B equals A, isn't it?
Yeah.
So, if grade 8.1 equals grade 8.2, then grade 8.2 equals grade 8.1, yes?
Yes.
So this property called symmetric property. Transitive property of equality. This is the similar idea of the law of Seligon. So if A equals B and B equals C, then A equals C. If this screen has the same price of the laptop and the laptop has the same price of the mobile phone, then the mobile phone and the screen have the same price. So if A equals B and B equals C, then A and C are equals. Clear so far?
Yes, so far.
Yes.
Substitution property of equality. Substitution in language means replacement.
Yes.
And you can replace only equal parts. It's like the football game when somebody got out of the playground and someone else inserted instead of him. These two people are equivalent because they are related to the same team and they are only one person get out and another one replaced him. So this is the substitution. For equations, we can substitute any two equal values. Like if A equals B, then A can be replaced by B at any of the equation. Let me give you an example here. Let's say that A plus B equals 5, an equation. And we have given that A equals 2. Now A equals 2, so I can replace this A with 2. So the equation now became 2 plus B equals 5 and can be used to get the value of B. So what I've done here, I've substituted A with 2. Why? Because they are equal. So I can do this. Easy so far?
Yes.
Distributive property. This to distribute multiplication among addition. So A distributed to every term inside the parentheses. So A distributed to B and C, which means that the sign in the parentheses will be the sign here, and others will be multiplication. I can demonstrate this by example. Let's say 2 plus 3, and I will distribute 5 to them. Okay? So this can be solved as 5 times 2 and 5 times 3. So this is 5 times 2 and 5 times 3. Yes? 5 times 2 is 10, 5 times 3 is 15. If I add 10 to 15, then the answer is 25. To make sure that this process works, you can easily check here, add BidMass says that we can finish the parentheses first. So let's add whatever we have inside the parentheses. 2 plus 3.
2 plus 3 is
5. So 5 times 5. We have 25 equals 25. So what I've done there, this distribution property of equality. For sure this is easier, but when we have algebraic variables like a, b, x, y, it could be like we could need this distribution property to find out. Okay. No, it's okay. Distributive property.
Can it also have variables like x and y?
Yes, yes. Here you are. Let's give you an example with variables. Like let's say 3a minus b. That's equal to distribute the 3 to a and to b. So 3a. Is it plus or minus?
Minus.
We are following the same sign here inside the parentheses. So it's minus 3b's. And these are different terms. It's a and b. So I cannot add them or subtract them. I'll keep it like this. And this is the answer. Mr. Ahmed, can you close your laptop, please? And pay attention. Commutative property. Commutative property. Okay, what's the commutative property? When A plus B equals B plus A. And when A times B equals B times A. This works only for addition and multiplication. It does not work for subtraction or division. And I'll give you a real example with numerical numbers. Let's say 2 plus 3. Isn't it the same as 3 plus 2? Yes?
Yes.
How about 2 times 3? Is it the same as 3 times 2? Can I try subtraction now? 2 minus 3. Is it the same as 3 minus 2?
No.
No.
2 minus 3 is negative 1, but 3 minus 2 is positive 1, so they are not equal. Also 2 divided by 3. Is it the same as 3 halves?
No.
No, they are completely different. So these are not equals. So the commutative property works only for addition and
Multiply.
multiplication. It does not work for subtraction and division. Associative property. It has a different name called the law of brackets or parentheses. It tells you that you can plot brackets or parentheses whenever you want if the expression has multiplication and addition only. For example, I can say 2 plus 3 plus 4. This is equal to the same 2 plus 3 plus 4. Feel free to plot the parentheses anywhere you want. If you make the parentheses here, it's the same as you made it here. To make sure you can simplify, 2 plus 3 and 4 are 7. And here, 5 plus 4. Are they equal?
No.
Let's see. 2 plus 7? And 5 plus 4? So feel free to plot the branches anywhere, if it has addition. You can also make like this. 2 plus 3 plus 4. These are lines. So plotting the branches anywhere is applicable whenever you have addition, but not with subtraction. So if I have 2 plus 3 minus 4, and here I have this, let's check if it's equal to 2 plus 3 minus 4 or not. Okay. 2 plus 3 minus 4? Agree?
Yeah.
Okay, 3 minus 4 is negative 1. Is it equal? 2 plus 3 is 5, minus 4. 2 plus negative 1, that is 1. 5 minus 4, that's 1. Oh, just for luck. No, I will check again. I will do a different example. Okay. Let's make 2 minus 3 minus 4. And if it's equal, 2 minus 3 minus 4. Let me plot the branches here. Okay. Let's check. 2 minus 3 is negative 1, minus 4. There, 3 minus 4 is negative 1, minus, like 2 minus negative 1. Minus negative is the same as
Positive.
plus. So 2 plus 1. Is it equal? Negative 1 minus 4? That is 3. And this is negative 5. They are not equal. So with subtraction, we cannot use associative. We checked if we can use it with addition. So it works with addition, but it does not work with subtraction. Am I correct?
Yes.
Now let's check with multiplication. 2 times 3 multiplied by 4. Is it the same as 2 times 3 multiplied by 4? We'll check. 2 times 3 is 6. 6 times 4 is?
44.
Excellent. Equals 2 times 3 times 4?
3 times 4 equals
12. And 2 times 12?
2
24.
times 12.
So, so they are equal. 24 are equal to 24. What if I have changed all of these times to be divided by? Okay. Let's divide. And check. Attention, please. 2 divided by 3 is 2/3. Divided by 4. Is it equal to 2 divided by 3 divided by 4?
No.
I will check. Remember that keep, change, and flip. Keep, change, and flip. Key save. So I will keep, change, and flip 4. 4 is the same as 4 over 1. So I flip it to make it 1 over.
4.
Is it equal to 2, change, flip? I'm not sure. Let's simplify. 2 times 1 is?
3 and 2.
2. And 3 times 4? 12. Is it equal? 2 times 4?
8.
And 2 is over 1. 1 times 3?
3. 2 times 3, 3.
Do you think these fractions are equal?
No.
Actually, this is a proper fraction. It's less than 1. And this is an improper fraction. There's more than 1, so they are not equal. So we have to check that associative does not work for division, and it doesn't work for subtraction. So associative works with
Division.
addition and multiplication only.
Oh.
Okay?